All right, guys, so I've had a lot of people asking me, kind of sending me emails and asking me after class, like, how do you integrate an absolute value function? So if you had some function absolute value, how would you actually compute that integral? Now, this is a great question, and we're going to talk through the strategy and then go through some examples. Basically, with an absolute value function is something that is always positive. So what we need to do is we need to count the positive and negative parts all as positive. Right? Because if we take the absolute value of -3, that gives you just +3. So what we're going to do in order to do this is we're just going to split this up when the inner function, that f of x, is equal to 0. I'm going to calculate the integral on each interval there. So on each interval. And then I'll add the absolute value of each part. So basically, I'm going to break it into parts. Like here's a positive part, here's a negative part, and then take the absolute value of each of those and then add those together. So let me give you a couple examples so you can see what this will look like. So suppose we have to do the integral from -2 to 2 at x. Okay, now your first thought on these problems is that I'm going to split them up when the inside is equal to 0. So when that x equals 0. Okay, so what I mean by that is like 0 is in the middle of -2 to 2. So what I'm going to do is I'm going to go -2 to 0 of this function plus integral 0 to 2 of this function. At this point, I've dropped the absolute value. Okay, so now what I'm going to do is I'm going to do each integral, and then I'll take the absolute value of each answer and then add those together. So in a sense, kind of what I'm doing is saying, all right, I'm going to do this from -2 to 0, take the absolute value of the answer, take the absolute value of the answer 0 to 2, and then add those. Okay, now let's do each of these separately. So the -2 to 0 is saying, okay, that's going to be x squared over 2, going from -2 to 0. So that's 0 minus. When I do -2 squared, that's +4, so 4 over 2. So that's -2. When I do this one, this of course is just the same antiderivative. Plug in 0 and 2. I'm going to get 2 minus 0, which is 2. Now, like I said, again, once I have these integrals, I'm going to take the absolute value of these, of each, and then I'll add those together. Okay, so I'll take the absolute value of the -2, I'll take the absolute value of the 2. Okay, so of course that's 2 plus 2, and my answer is 4. And sure enough, that is the integral from -2 to 2 of absolute value x. Okay, so what you're doing is graphically, if you graph like y equals absolute value x, of course it makes the V shape. And sure enough, if you go from -2 to 2, you have two triangles that both have a height of 2 and a base 2, so that's 2 and 2, so that's why it adds up to 4. Okay, so we got an answer that makes sense to us. That's terrific. So that's the key. We split it up when the inside is 0. We're going to go ahead and do each integral, take the absolute value of each part, and then add those together. Now let's look at another example, right? Suppose now we're going to do a slightly more complicated one. 0 to 3 of absolute value x squared minus 4. Okay, so again, look at this. We look at the inside. So we split this when the inside is 0. So the inside in this case is x squared minus 4. So when that's equal to 0, that means x is plus or minus 2. Now, -2 doesn't matter, right? It's not between 0 and 3. So if I'm trying to break this up, I'd only break it up at 2. So I'll go integral 0 to 2 of x squared minus 4. And then I'll do integral 2 to 3 of x squared minus 4. Take the absolute value of each of those and add those together. Now the great thing here again is we've broken it up into a problem that's easier to solve. You guys know how to do both these integrals. They're very straightforward. That's x cubed over 3 minus 4x going from 0 to 2. So when I plug in the 2, I got 8/3 minus 12 minus 0. Okay, oh geez, that's 8/3 minus 24/3. That's negative 16 over 3. Okay, this integral probably going to be about the same, going from 2 to 3. Okay, when I plug in 3, I'm going to get 3 cubed is 27 over 3 is 9 minus 12. When I plug in 2, I actually get the same thing, so that's kind of cute. 8/3 minus 8. Oh god, how stupid am I? I just realized I did the other problem wrong. 2 times 4 is actually 8, so let's clean this up a little bit. So luckily 2 wrongs do make a right, because 8 is indeed 24/3. Okay, cool. That worked out really nicely. Excellent. I'm an idiot. Good. So as we go ahead and plug this in, so we'll have -3 minus 8/3 plus 8. So that'll be 5 minus 8/3. So that's 15/3 minus 8/3. So that, of course, is 7/3. Okay. So those are my two integrals. Now again, I'm going to take the absolute value of each, and then I'll add them together. And of course, taking the absolute value of a number is extraordinarily simple. So this would just be 16 thirds plus 7 thirds. So I got an answer here of 23 thirds, assuming I didn't make any other arithmetic errors. Okay. So that's how you, I'm sorry for my arithmetic there. That's how you do this. Again, we didn't split it up at -2 because it wasn't within the bounds. Now, one thing worth noting is if this were the integral from, I don't know, like -10 to 10, we'd have to go from -10 to 2, -2, and then I'd have to go from -2 to 2, and then I'd have to go from 2 to 10 and do those three each individually. Okay, so that's how that works. Okay, let's look at one other example that's seemingly unrelated. So if we did integral 4 to 7 of square root of x squared minus 10x plus 25. Now, when you look at this, what might your first thought be? Well, maybe you're thinking, hey, let's do a U-sub. Let's do a U-sub. Okay. And of course, you might try that, but then eventually you find that you're kind of up a creek without a paddle because du is 2x minus 10, and we don't have that at all. So that doesn't work. But then I might wonder, maybe I can factor this. And in fact, I can, right? This is equivalent to the integral 4 to 7 of square root x minus 5 squared dx. Okay. Now at this point, the question you want to ask yourself is, what is the square root of x squared? Now, almost all you guys got that wrong because the answer is not x, it's actually the absolute value of x. That's what the square root of x squared is. And that makes sense because if you take the square root of 3 squared, of course, that's root 9, which is 3. If you take the square root of -3 squared, that's actually square root of 9, which is also 3. So it just takes the absolute value. So that's a cool trick. The square root of x squared is not just x, it's absolute value x. So what that means is you can use this to simplify and write this as integral from 4 to 7 of absolute value x minus 5. Okay, now, I'm not going to finish this problem from here. If you'd like to, you can. Anyway, the answer you should get is 5/2. So feel free to do that on your own. But the idea here was that you could use a factoring trick to just rewrite that. You're not going to see that a ton, but every once in a while. Okay, so the next thing I wanted to do is show you a graph. So I'm going to say here is a graph of f, and I'm going to give you some areas as part of this. So the areas given. Okay, so I'm going to give you a graph from 0 to 8. And originally the graph is going to start up here. Woo! Okay, and this area above the curve from 0 to 4, we'll call that 9. The area below from 4 to 8 is 3. Okay, so now part A of this problem is going to be very straightforward. I'm going to ask you to find the integral from 0 to 8 of f of x. Part B of this problem, I'm going to ask you to find the integral 0 to 8 of absolute value of f of x. Okay, now the first part, that's something you could have done like a month ago, right? We have a positive and we have a negative. So we just say, okay, we have a 9 above the curve, we have a 3 below, that's 6. Now, geometrically, when I'm finding an integral of the absolute value of f, what I need to do is I need to count each area as positive. So I'm basically, in essence, doing what I did before. I'm splitting it up at the 4, going from 0 to 4, which is 9. And then instead of thinking about this as a negative area, I'm kind of saying let's take the absolute value of that part under the curve and just get 9 plus 3, which is 12. So that's how it's working. We count each area as a positive, either above or below the curve. So that's the difference there between graphing an f and an absolute value f. Okay. Thanks for watching, guys. Hope the tip helped about splitting this up into different parts, doing them all, and then taking the absolute value. And I'll see you guys soon.